Since you got number one.
All right, so number one. I don't have the question pulled up on my computer, but it has to do with epigenetic inheritance. So number one, you're going to do a cross, and you're going to end up with two dominant A's and two recessive A's. Your genotype is going to be a 1 to 2 to 1, and your phenotype is going to be a 1 to 1. For B, you are going to do two recessive A's, a cross with two recessive A's and two heterozygous A's, and you're going to end up with a genotype of 1 to 1 and a phenotype of 100%. For C, the bar body questions, they're rough like always. For C, I put 0, and for D, I put 2. Then moving on to question 2. Fill in the blanks. I'll just read off the answers. So we have SRY as number 1, Mike 2 gene as 2, 50% normal, 50% dwarf as C, sex influenced as D, genomic imprinting and dosage compensation for E. F is XIST and T6. G is autosomal and X chromosome. And now on to number 3. Has to do with the woman's father and all that good sweet stuff. So for 3A, to get that result, your parents would have to be, your female would have to be homozygous dominant, and your dad would be recessive on the X, so he'd have a small b. For B, the answer is a 4th, and you just get that by doing a Punnett square. Pretty simple. For C, let's see what C is asking so I can say this correctly. Identify the genotype of the male. Okay, so the genotype of the male would be an X with a D and a Y. And then for the last one, you're going to end up with one female with OTD, one female with no OTD, one male with OTD, and one male with no OTD. So you're going to have a 1 to 1 to 1 to 1 ratio. Spencer, take it away.
All right, cool. I was just going to show you our work for number 3 because it's a little confusing. I ended up switching my D's and R's halfway through, but you know, that's fine. It's still the same thing. But that's what we got. And then for number 4, hopefully my picture is clear enough for you guys. A is asking for what would the genotypes of the parents be in order to get a 3 to 1 male offspring ratio for bearded to non-bearded. And so that'd take a non-bearded female, but she's heterozygous, and it would take a bearded male who's heterozygous as well. So that'll get you 3 to 1 for males. And then B, it'll ask you for a 1 bearded to 3 non-bearded female offspring ratio. And you actually use the same genotypes for the parents. They'll both be heterozygous. So a non-bearded female that's heterozygous for it, and then a bearded male that's heterozygous, and that'll get you that. And then C, it asks how you can get a 1 to 1 ratio for female offspring for bearded and non-bearded. And so that would take a non-bearded female that's heterozygous again, but the bearded male is homozygous dominant, so he's got 2 big B's to pass around. And then for D, it's saying that both parents, the mother and father, lack beards, but their male offspring it's 1 to 1 for bearded to non-bearded. And so we know that the male has to be little b, or homozygous recessive, and then that means that the mother is heterozygous again, and so she can pass on the big B, and that's how you get that. And then for number 5, let me flip to my notes. A is asking, it's talking about the cats again, which, I mean, we watched the videos on it. But it's saying, suppose that we cross an orange male cat to a tortoiseshell female. What are the genotypes and phenotypes of the progeny? And so for her, at least for the variables I used for the female, we have an X with a big B and an X with a little b, and that'll get you your tortoise shell. And then the male is an orange, so he's X little b, and then he's got his Y chromosome. So you do a cross and you get your 4 different genotypes. And our phenotypes is we'll end up with 1 tortoiseshell female, 1 orange female, 1 black male, 1 orange male. And then for B, it says male tortoiseshell cats are very rare. So what is the genotype of one? And in that video, the Bozeman science video, he tells you exactly what it is. But we're going to have an X big B, X little b, and a Y chromosome. And that happens when a non-disjunction occurs. So it's very rare. And then C is talking about the fruit flies again. And it talks about the scalloped wings and regular wings, I guess. And so it wants you to do a reciprocal cross, and so we know that they have to be true breeding, so dominant and recessives. And so for C, up there I have X big B, so that would just be a normal female. And then the male would be X little b, and then his Y chromosome. So he'd be scalloped, I guess. And what that gives you is you'll end up with 100% normal wings. And there's 2 different genotypes you can have. Or you can flip it, and the mother can be recessive, and the father can be the dominant, and that ends up getting you 50% normal, 50% scalloped. And that's the males that will get you scalloped. The margins on their wings, and the females will still be normal. And then D, it's asking for autosomal, and so we don't have to do the sex chromosomes. And it wants you to indicate the genotypes and phenotypes of the progeny produced when the reciprocal crosses are done. So either way, you're going to get a 1 to 2 to 1 ratio because you're going to have all heterozygous offspring. So whether it's the dominant male or recessive, it doesn't matter. They'll flip. It'll still be 100% heterozygous, and so they're all going to have normal wings. So that's kind of how we did it, at least. But I hope that made sense. All right, thanks.